Okay, so this morning I sent you an email with an attachment which is sort of a supplement to the marking scheme. It was just some notes I had made last time I corrected assignments similar to that. So it should kind of give you some idea of maybe what you need to do within each of the categories. I'm wary of calling it an update to the marking scheme because it's probably not the final thing. You can only decide so much in advance. And so it might vary a little bit, but we'll give you kind of an indication anyway of what level we're looking for. Okay? What I'm going to do today is we're going to look at some different strategies you might use to code various checksum algorithms. We're going to look at the one for the GoodDNI or DNI, the Spanish ID number. And we're also going to look at some samples of code that I got on the web for the learn algorithm for credit cards. So just to see some of the different kinds of things that people do. Last week I put on the blog a video with some extra checksum calculations. What's this number? How's this pronounced? How do we pronounce that? What do we call this? Any Polish person? How's it pronounced? Pesel. Okay, what's it stand for?
It's like PPS number.
What's it stand for literally? You don't know?
Personal something.
Is it personal or Polish or? Anyway, whatever, okay? So I put that on the blog there as a video. I also talked through this and French one there, okay? Now, so how might we go about coding some of these things? You want to try and avoid writing Muppet code. So in a situation like this, for example, where we have, if it's an A, then the number is 1. If it's a B, then the value is 2. If it's a C, then the value is 3. And if it's a D, then the value is 4. It's really sad to see code that says if C equals 1, then X. Sorry, if C equals A, then X equals 1. Else if C equals B, then X equals 2. Else if C equals C, then X equals 3. Else if C equals 4, then X equals, it's just really painful to see that when there are cleverer ways. So where you have A, B, C, D, E, F, G, H, I, and you know they're all there in a row, one after the other, generally where you have things lined up in a row, you can use the fact that they're all lined up for you. So a sensible thing to do in a situation like that would be to take the character and get the ASCII value of it. Because the ASCII value of A is 65, B is 66, C is 67, D is 68, 69, and so on and so on and so on. So if you take a character, get the ASCII value of it, and subtract 64 from that value, well, then you have a function that'll map from letters to numbers in the way that you want. Let me see what I'm saying there? I'm talking about? Rather than doing, if this, then this, else if this, then this, like 26 times. In the Europa series banknotes, there's a couple of ways to do that, but this first letter does, A, 1, 2, 3, 4, and the next one does 11, 12, 13, 14. Having written a function that transforms letters, would take A to 1, B to 2, C to 3. You wouldn't go away then and do another one that does A to 11, B to 12, C to 13. You could write one function that just uses the other function and adds 10 to it, or just add 10 to the thing somewhere else. Do you know what I mean? You need to be clever about such things. So what we're going to look at today now is the code for the DNI. And if we consider the algorithm again for this one, it's really not that complicated. It'd be one of the simpler ones were it not for the little twist at the end. So we take the numerical part of the number. Do we have an example of one there? So we take the numerical part and we treat that as a big integer. We do a mod 23, which gives us a number, and then that number gives us an index into this table here. So if the mod 23 gives us 10, then the letter is X. And there's just a variation on that, in that sometimes people separate the letter part from the number part with a dash. So sometimes the dash is there, sometimes the dash isn't there. Marina, do you always use the dash when you use yours? Depends. Okay. So, so in the Irish scenario, you have, A is 1, B is 2, C is 3. Here it just seems to be random. I've asked a number of people, is there any logic to this? And no one seems to know why the pattern is the way it is. It may have been a secret at some stage, we don't know. Okay, so that's the algorithm. So what we're going to do now is we're going to look at actual code to do that. Okay, I'm going to look at the various steps. So we're going to go from the algorithm to the actual code, okay? And I'm going to try and talk you through that as best I can by way of example of how you might do one. Okay? This is it at work. Sorry, it was just an alert there while I was debugging. That's dodgy. That's good. And that's also good. Okay? So we need to account for with or without the dash. We need to account for lowercase or uppercase letters. So we need to account for some of those things too. Okay? So I printed out the code there for you, and hopefully your line numbers are the same as mine. Okay. And let's not make it too big. Okay. So we have a function here called GoodDNI that's going to evaluate to true or false depending on whether the number is good or not, whether the string passed in is good or not. Okay, so here in a function called checkNumber, which is triggered when you click the button, we're hoovering up the input there from the form. So the number they get typed in gets put into num, and then num gets passed in to GoodDNI. That comes back with true, we say yip-de-doo. If it comes back as false, we say we're not happy. Okay, so that's the straightforward part, but we need to look here now at this DNI function. Okay, so sometimes it's 8 digits followed by a letter, and sometimes it's 8 digits followed by a dash followed by a letter. So here we go. Let's take a look. So we want to output the number that the person put in and say we think this is good or we think this is bad, but we might transform it in the meantime by converting it to uppercase, lowercase, or removing the dash. So the first thing we're going to do is to just make a copy of it so that we still have the original one. As it turns out, I guess if you pass in the number and it gets changed inside the function, I guess it doesn't change outside the function. We'd have to look at the scope of things passed in JavaScript, whether they're passed in by value or by reference. If you don't know what that means, you'll need to figure that out before you leave college, but it's okay for now. This is just a safety precaution anyway. Okay. So we're just preserving the exact one that was put into the function just in case we need it somewhere along the way. No. So it can be 9 characters long or 10 characters long. As I've suggested as a strategy for doing this in the past, assume it's okay, assume it's valid, and then if there's a problem, it gets shot down. just make sure you never pick it back up again once you've shot it down. So if it's not 9 characters long and it's not 10 characters long, well, you know, we can already say we're not happy. Okay, so we can declare false there straight away. No. This is a bit tricky now, okay? Not the code, actually, just the logic of it. If it's 10 characters long, that's okay, provided the second last one is that dash. So it can be number, 8 of those. Maybe a dash, maybe not a dash, and a letter. If it's 10 characters long, we have to have the letter at the end, and the second last one must be the dash. Okay? So if it's 10 characters long, and if the second last one, which is at 8, is a dash, then what we're doing here is we're stripping out the dash. So we want a version of it with no dash. So once we've got past it, then we're just assuming it's in the format that we want, which is without the dash. So we can carry on. Now we're not really stripping out the dash. What we're doing is we're reconstructing the string, okay, by taking the piece before the dash and adding it to the piece after the dash and sticking them together. So this is the alleged numeric part, and this is the alleged letter part at the end. And so we're basically rebuilding the string without the dash. If it turns out there wasn't a dash there where there was supposed to be, well, look, we're not happy, that's going to be false. So we're doing a couple of jobs there. We're checking to see if it is got the dash where it's supposed to be, and if it does, we're stripping it out. So now we know we have 8 digits and a letter. Okay, yeah? Any questions so far? So this substring here, look, is giving you a section of the string DNI, which is just the number part. So we take the first 8 characters of the string. So we take positions 0 to 7, which is 8 altogether. The first one is always 0. And we convert that to a number using parseInt. And don't forget the 10. So now the numeric part is in an integer. The next thing we want to do is we want to extract the letter at the end and put that into a variable called DNI letter. It could be uppercase or lowercase. Rather than do if it's lowercase, do blah blah blah, else blah 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 blah, we just force it to be uppercase and get on with our business. So this is forcing the DNI letter to be uppercase. So if the person typed it in as lowercase, we're forcing it to be uppercase now. And then we do the mod 23. So now we have a variable here, DNI mod is DNI num mod 23. Now there's a problem here. The testing wasn't rigorous enough. It's possible that there was some letters mixed in with that part there. It's possible they did 1, 2, 3, P, 4, 5, 6, X at the end. We really should have code here before we start doing maths on that ensures that every single character in that was a digit. So we saw an example of that with the phone numbers, where we took each string, we took each character, and we said if it's less than string with a 0 in it and greater than a string with a 9 in it, then it's dodgy. So we really should have checked if all of the characters were digits before we converted it to the number. So a number of things could have happened here. Parsint might have taken the dodgy number part and had a stab at converting it to an integer, in which case it'll carry on and just the answer will be wrong, so we know something was dodgy. Or of course it could just have a tizzy fit, keel over and die. So you need to guard against possibilities like that. I mean, if your program gives you the wrong answer, that's bad. If it bombs out and collapses and crashes, that's much, much worse. So I suppose we could look at the spec for Parsint and just be happy that, satisfy ourselves that if you do give it dodgy input, it doesn't explode. Okay, but it would be better to check each character to see if it was actually a digit. Okay, so now here we're doing our mod 23, and so now we have a value between 0 and 22. So in the case of a PPS number, we could add that value to 65, and that would tell us what letter we should have, or 64, depending on where you're starting at 0 or at 1. That doesn't work here though, because this is somewhat made up. We saw in the case of the finished one, it went 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then had some letters, but it didn't have letters that might have been confused for other characters. So it didn't have an O, didn't have an I, didn't have an L, didn't have a G. So that's not quite as arbitrary as this, but it's still as awkward as this. But we have a workaround. What you don't want to have here now is, if DNI mod equals 0, then letter equals T. Else, if DNI mod equals 1, letter equals R. Else, if DNI mod equals 2, letter equals W. I mean, my heart sinks when I see stuff like that, because there's no need for carry on like that. Okay? There are cleverer ways. So what I have here is I've gathered up these things into a string called mad string. And what we're going to do is we can map from the number to the letter by using the position of the character in the string. So T is at position number 0, R is at position number 1, W is at position number 2, A is at position number 3. So the position of the letter in the string maps to the value it should map to. If we go back to here, look, 0 is T, 1 is R, 2 is W, 3 is A, 4 is G. So char at gives you the particular character at a position in a string. So char at 7 for this string is 0, 1, 2, 3, 4, 5, 6, 7. So char at 7 is F. So here we're saying DNI letter 2 equals, in this case it'll turn out to be F. So we have the letter that appears at the end of the ID number that was input. And based on the number, we've worked out what that letter should be if everything was okay. So now, all we need to make sure is that the letter that the person put in and the letter that we calculated it should be are the same. So if DNI letter is the same as DNI letter 2, then that's good. Now, we can't say if the two letters match, the number is good. Remember, once we knock it down, once we shoot it down, we can't pick it back up again. So we can't say if the letters match, everything is good. All we can say is if the letters don't match, that's bad. So we're saying if they're not equal, that's the not there, then the number's dodgy. So can you see the steps we took there? Does anybody want me to answer questions now about any particular part? Any of the code there we haven't seen before? I haven't seen a lot of. I don't know if we've seen much of substring, but the name is, clues in the name. In terms of the logic, does everybody get the logic there? I think the only non-obvious thing is putting all these into the string here and then using their position in the string to map to the number. Excuse me. Any questions on any of that?
The 10 in parse out was the base, right?
Yes.
It defaults to 10 if you don't put it in, does it?
Not always. You would think it would default to 10 all the time, but no. If the string starts with a 0, it assumes the base is hexadecimal. Like I said, when I am king, the person that did that will be shot. Okay? So, and if it starts with 0x, I think it assumes octal. Okay? So that's why you have to put in the 10. I was going to say 9 times out of 10 it wouldn't matter, but literally 9 times out of 10 it wouldn't matter, and 1 time in 10 it would matter. If your number happens to start with a 0, then the whole thing goes horribly wrong. And I've seen that happen to people, and they've tested their code and everything's fine, everything's fine, everything's fine. Then Colin, the code wrecker, comes along, puts in something that starts with 0, and the whole thing fails. So you must put in the 10, unless it's a scenario where you're guaranteed everything's going to be okay. So you may have seen examples where there was only one character in the string. Well then, 0 decimal, 0 hexadecimal are still 0. And everything else would be the same. So it'd be okay. Except, yeah. Any other questions? You need to be careful with the capitalization of some of these built-in functions. If it's a small u there or a lowercase c, you're screwed. I've seen people forget this. I forget this myself. In a Boolean expression, if you want to test the two things are equal, it's equals equals. And equals on its own is an assignment statement. And that can trip people up. But the main thing here I want to do is just to go from the algorithm, step by step, all the tests you want to run on the thing, into the code. Now, I'm kind of old-fashioned the way I write my code. Obviously, a function only has one way in. I like to have only one way out. So I like to make up my mind about what I'm doing and then at the very, very end, give back the answer I came up with. It's either true or false. Okay? However, if you think about it really, here I'm saying if it's not length 10 nor length 9, then it's dodgy. Well, really, that's enough. I don't need to do anything else. So if I was being pedantic, every step after that, I would only do if valid was true. If valid is false, there's no point in doing any other tests. In fact, it might be a bad idea. If this string was empty and I'm trying to do stuff, I could cause it to crash. So I should only be doing the subsequent tests if everything so far has already passed. But more significantly, it's perfectly reasonable, I think, at this point to say, you know, stick a fork in me, I'm done. Like, I mean, this is false, the number's dodgy, the function's finished. You could return false right here. Instead of saying valid is false, just return false. You know, bomb out of the function and go back to where it came from with your answer. It's certainly safer because then you're not trying to do tests on input you know to be dodgy. I mean, it's a bit wasteful to be doing tests on stuff you know is bad anyway, but it's also quite dangerous because it could cause a crash. You know, if the input's dodgy, oof, you know, do you want to be looping through it or whatever? So you can return false here. One of the dangers, though, is that if your code is complex and you've lots of ifs and elses and stuff, you may find that there's a scenario in which you don't come back with any answer at all, in which the function never goes home. So that's why I'm in the habit of, you know, figuring out everything and then at the end returning the value. But really you could return it everywhere you've declared it false, everywhere you've decided there's a problem. The function could be done then. But you just have to be really, really careful that you always return and go home. Okay? So that's why I just put that comment there. If we look at this, that was just a thing we saw that kept coming up. That was just while I was debugging. I had an issue, forgot to take it out. There's nothing strange or startling here that we haven't seen before. We're using get element by ID to change the background color of some text, and we are also changing the inner HTML of that div. I suspect could be a span. I believe it's a div. To say this number looks good or the number looks bad. We haven't addressed the question, if I pass in this string here to the function and the function changes it, chops it up, when we come out of the function, is it unchanged or not? We'd have to look up how JavaScript does that. A proper grown-up programming language would, by default, not change it. As you know, with JavaScript, all bets are off. Like, who knows? Okay. And it turned out it was a div. Yeah. Okay. So, any questions now on any of that? Okay. So what I want to look at now is on the other sheets is just some snippets of code I got when I was Googling the learn algorithm for doing credit cards. Interestingly, I didn't find anybody who would have done it exactly the same way I would have. I think if you only had the notes from this module, you would nearly all do it the same way. Needless to say, on many occasions I've seen snippets of code from the web. So much so that if you look at the revised marking scheme, not revised, sort of fleshed out marking scheme, I'm really not giving any marks for the credit card number anymore. Not because it's not that hard. It's also the most useful, most widely used checksum you would possibly do in JavaScript. It's just that I'm sick of all the cogging of, this is the most cogged thing in the world. So, I mean, I'm not going to give you a speech now about, lifting other people's code from the web. You can, do that, take your chances and see how that works out for you. Who knows? Some people have got away with it in the past, some people haven't. It's fairly hit and miss. But for this anyway, for the assignment, you can just take code from wherever you want and just say where you got it, and that'll be fine. If you take code, I'm basically just going to assume that you didn't write this code yourself. Okay. What I'm going to do now is just go through some snippets of different ways to do it. Okay? There's a thing you can do with regular expressions that's really handy. I used to be a regular expressions guru, but I've long since forgotten how to do that. But what you can do is you can set up a regular expression in a variable, and then you can ask JavaScript to see if the string you're talking about fits the specification for the regular expression. So if, for example, you wanted to, in the DNI, to check that the first 8 characters were digits, and check that the last one was a letter, and then maybe it has a dash, maybe it doesn't, you could write a regular expression for that. It would be a nice short one, and then you could use this here to compare the input with the regular expression, and then it would tell you straight away whether it was good or bad. Or rather, it would tell you it was bad straight away. Okay? So you can do that. I mean, for a credit card, it's easy enough. It's just supposed to be 16 digits anyway. But what you see is a lot of people. So this guy here is checking to see if it's a Visa. So you see, Visa number must start with a 4. And then you can have any digits after that. And so on. Okay? I think that he might be accounting for, I would have thought all Visa numbers were 16 characters long, but maybe he's accounting for different length ones, I'm not sure. But anyway, so if you're into regular expressions, you can show off a bit by writing a regular expression for the thing you're trying to test and compare it using that. Okay? So if you see something like this, you can use that. I think in many years of teaching that module, of all the people that use regular expressions to do stuff, only one person actually was able to tell me what the regular expression meant. Okay? But it can be a way to save some time. Okay? So just to recap on the learn algorithm for the credit cards, you multiply every second digit by 2. And then you add up all the digits that you get, essentially. So you might have, the first one you might not multiply, so that might be a 2. You multiply that, you don't multiply that, that just becomes 2. The next one might be 2, and it gets multiplied by 2 to give you 4. The next one might be a 3, that doesn't get multiplied. The next one might be a 6, that gets multiplied by 2, which gives you 12. So when you multiply, so then when you add those digits together, you should get 3 added into the total. 1 and 2 from 12. Okay, if you go back and look at the algorithm and see how that works. There are a couple of ways to do that. One trick is to, if the number is greater than 9, then subtract 9 from it. So 12 minus 9 gives you 3, for example. 16 minus 9 gives you 7, and 1 plus 6 gives you 7, so that's good. Did we discover that 1 plus 8 though was dodgy? 9, 9, 18. 18 minus 9 is, no, that's fine too. So if the number is greater than 9, that works. Okay, so that's a trick. That's one way you can do it. Rather than extracting out the first digit and extracting out the second digit and adding them together. Which you could do with mods and divs if you have a mind to as well. Okay? Generally, when you find examples of this, they take different approaches to coding the every second thing. So every second thing gets multiplied by 2. There's different ways of dealing with that. Okay, let's look at this one here. So this looks fairly familiar. We have our for loop counting through them. Okay, and we extract, the ith character from the string. We convert it to a number, and then we're checking here to see are we on the odd one or the even one. Okay? There's an extra complication there in that if you don't know the length of the string, and if you don't know if it's an odd length or an even length, you may have to start at the back, because the last digit doesn't get multiplied by 2, so we have to start at the back and work forwards. But if you're confident of the length already, then you know, like, you can do odd, even, odd, even, odd, even, or even, odd, even, odd, even, odd. I mean, if you know the length for certain, then you don't have to worry about that. You can start at the start and work forwards. So by doing an I mod 2 here, he's basically checking to see if it's even, you do the multiply by 2. Okay? So if it's even, you multiply by 2. Otherwise, you don't multiply by 2, and you just add the digit in. I thought this was particularly clever, and I hadn't seen it before today, was this guy isn't doing his running total numerically. He's building up a string of digits. So if the first digit was 2, that doesn't get multiplied by anything. So 2 gets just put into the string. If the next digit was 4, that gets multiplied by 2, which is 8, and 8 goes into the string, added on, appended onto the string. If the next one was 1, that doesn't get multiplied by anything, that's an even one. 1 gets added into the string. And let's say the next one was 8. 8 multiplied by 2 is 16, right? And rather than deal with then, what should the 16 add up to? Do we do the mod and div to work that out, or we do the trick where we subtract the 9? He does neither. He slaps a 1 and a 6 into the string. So that 8 has become 1, 6. Okay? And you're thinking, okay, I'm still with you here now. I'm not sure how it's all going to end, but okay, fair enough. And then what he does is he loops through this new string and sums up all of the digits. So that 1 and 6 do eventually get added together to 7, to all the other digits. So he's taking the algorithm as we first expressed it quite literally, where you add up all the digits. And he's kind of getting away with that because of the ability of JavaScript to treat numbers like strings when it suits it. So here he said t is a string. So when we do t is assigned t plus c, if he adds 3 to t, he's not adding the value 3 to the value of t, he's adding the character 3 to the string t. So this t is a string line here is actually the linchpin of the whole thing. If he said nothing about t being a string, it would have assumed it was an integer, and what he would have got was a number at the end, which wasn't quite the same thing at all. So I thought that was quite clever, although it might fall into the category of too clever. Like if you're too clever, the programmer that comes after you to modify the code or fix the code or maintain it might have difficulties. So you don't want to be too cryptic. I also don't like the fact that he's doing a bit of type magic. I mean, here it's an integer, but here it's a string. I'm not sure if we could consider that good practice or not. But I suppose JavaScript does allow it, so why not use that? So I thought that was quite clever. But like I said, possibly too clever. Can anybody see an issue with this? Like here we're doing t dot length because we don't actually know the length. Because some of the digits might have been double, some of the digits may have become 2 characters. One of the problems here is that this will only work for even length numbers. If it was an odd length number, he'd be multiplying every second one by 2, but it'd be every second wrong one. So there's a bit of a flaw there. He could have solved that problem by starting at the length of the string and counting backwards down to 0. And at least then he would have, by starting at the end, he'd be multiplying the correct second one, every second one by 2. I've seen this a lot on my travels. Bizarrely, students who copy are often too lazy to change the variable names, which just strikes me as extraordinary when it's so easy to do. Because you can just do a find and replace on the variable names. It takes 5 seconds. And what makes this stand out is actually parity doesn't mean what this parity means something different to what's really happening here with this variable. This is fairly straightforward. This is probably the most likely way you would have written this anyway if left to your own devices. It strikes me as the most sensible solution apart from the odd choice of variable name here. So we start off with our running total. We're just putting the length here into a variable just for convenience. Okay? Actually more than convenience. And what we're doing here is this parity thing is trying to solve the problem of is it odd or even? Because if it's an even numbered credit card, if there's an even number of digits, you have to go don't multiply, don't multiply, don't multiply, don't multiply, don't multiply. If it's an odd number, you have to go multiply, don't, multiply, don't, multiply, don't, multiply, don't, multiply, don't. Did I do that right? Anyway, I either did it right or the exact opposite. Right? But there's 2 different ways. So that's what this variable here is trying to sort out. Okay? So it does loop then through the length from 0 to the length of the string. And this here is extracting the ith character from the string, doing a parse int. You'll note the absence of the base parameter. Is that a problem here? Well, the worst that could happen is 0 decimal might get mistaken for 0 hexadecimal, which turns out to be 0 anyway. It's only 1 character long, so it's not going to cause a problem. So now digit is the number there. Here, in the simpler form of this, you would have said here, if I is even, then multiply by 2. If it's odd, don't bother. What it's doing here by saying if I mod 2 equals parity, then basically you're going to multiply by 2 if it was even, depending on the length, or odd, depending on the length. So you're not committing here to either an odd length or an even length one. For your assignment, we're going to assume a 16-digit credit card number. So you can dispense with this complication. So this guy was trying to write, I say guy, it could have been a woman, was trying to write a generic piece of code that would work the same and would work properly if it was an odd or an even length. Okay? Because you multiply every second one by 2. So if it's an even amount, you do multiply, don't, multiply, don't, multiply, don't. If it's an odd, you do don't, multiply, don't, multiply, don't, multiply, don't, multiply, don't. So it's a bit more complicated than it needs to be, but your solution would likely have here if I mod 2 equals 0 then. So we multiply the digit by 2, and then we solve the adding the digits together issue by doing the subtract 9 trick if it's greater than 9. Either way then, we add that into the total. Personally, I'm not a lover of this shorthand, but I didn't grow up with it. I like to have my sum is assigned sum plus digit, but this is fine if you're used to it. I know the young people like to do it that way, save a few keystrokes. Okay, and then if the sum mod 10 is 0, so if it's evenly divisible by 10, we're happy. I don't like here, well no, I do like it. He's returning here the Boolean true or false then. Okay. A really sloppy programmer might have used the fact that 0 is false and something not 0 would be true. So they might have just returned sum mod 10, or he might have returned, no, he wouldn't have actually, because that would be the wrong way around. But anyway. So this is the Boolean true or false here that gets sent back. Okay. Anything else interesting here? There must have been something I found interesting or I wouldn't have bothered. Okay, this guy here is trying to solve the problem of, is it multiply, don't, multiply, don't, multiply, don't, or don't, multiply, don't, multiply, don't, multiply, don't, multiply, don't. If it's odd or even. But he's doing it in a Boolean variable. And so every time you go around then, he toggles it by saying alt equals not alt. So he's keeping track of whether it's sort of going, left, right, or right, left, right, left. So every second one, he's doing it that way. Again, that's not something you'll have to worry about because you'll just assume they're 16 in length. Also, instead of doing the subtracting 9 if it's greater than 9 trick, he's taking the second digit of the number by doing a mod 10 and adding 1 to it. So again, he's taking the algorithm quite literally in that you add the digits together. But he knows that the first digit must be 1. Just add them together there. This here is quite cumbersome, I think, and I think it also falls into the too clever category. So what this is doing is it's looping through one by one, extracting out the digit. Note the absence of a parsings there, we really should have one. And then instead of trying to decide whether we should multiply it or not by 2, he multiplies it excuse me, he multiplies it by factor, okay, and then every time he goes around the loop he changes factor from, if it was 2 it becomes 1, if it was 1 it becomes 2. He does that by adding 1 to it and doing this is doing factor mod 2 plus 1. I would have done factor plus 1 mod 2, but I guess it works out the same thing. So he's not doing an if to see if you should multiply or not. You always multiply by factor, but every time he goes around, he changes factor. So factor does 1, 2, 1, 2, 1, 2, 1, which is kind of the same. Okay. So a couple of different ways there to skin a cat. in your case, you can assume it's a 16-digit credit card number on which you operate the loan algorithm. If you want to be fancy, you can have tests to see if it's a Visa or a MasterCard or whatever and reflect that somehow. But you needn't worry, I think, about the scenarios where it's odd. In any event, there aren't really many marks going for writing the code for the credit card check. What marks you, the reason it's worth your while doing though, is that you will get some marks for like integrating it into the whole thing. Okay? So you want to look at some other ones and see if you can code them up, because there's a section in the marking scheme for those. I think there's 10 marks in total going for those.